Implementing aiming in an isometric game is not hard, but not entirely obvious. I will show you how to make something like this and this. You can find the project on my GitHub. Click the link in the description if you only want to see the solution, but keep watching if you are interested in the explanation as well. Either way, I would recommend you to copy and paste the code from the link instead of typing. To look towards the mouse, we have to know where is it in 3D space. To figure it out, we will raycast through the position of the mouse from the camera. If you are not familiar with raycasting, think of it like pointing with a laser pointer in real life. If the laser hits something, we can get some details about the hit, including its position, which is what we want to know right now. Let's see how we can translate this to code. We need a camera reference to catch the main camera on start, also a layer mask. I will explain why later. The camera provides a function that will give us a ray going through the specified pixel coordinates. We want to pass in the mouse position for this method. I would like to know two important things about the raycast. First, that it either returns true or false, depending if it hits something or not. The actual data will be copied to the hit info variable. Secondly, that a mask can be used to ignore colliders on certain physics layers. It depends on your use case, but you probably only want to include the ground layer in this mask. If I include obstacles too, I could aim at the wall, which could be useful in some cases, but considered a bug in others. It's very unlikely that you want to include enemies or the player in the mask, so take your project into consideration when you are setting up the mask. We return the mouse position if the raycast hit something, or 0 vector if nothing was hit. Now that we got the mouse position, we just need the direction towards that. To calculate the distance from point A to point B, we just have to subtract the coordinates of point A from point B. We calculate the distance like this and set it as the forward vector of the transform. This will rotate the game object to look straight at the target, like this. This could be what you want, but in most cases, like when you rotate a character, you probably want to aim at a constant height. We can achieve this by simply zeroing out the Y component. Now we just have to call aim in update. Check out the project on GitHub if you get stuck, and don't forget to leave a nice comment, like and subscribe.